how to create the root mean square error. I've got some data in my L1, L2, and I'm going to create a model line and calculate the residuals and use those residuals to find the root mean square error. And then I'm going to use that root mean square error to make a prediction that includes a range of values. So let's get started. So as you can see, I've got my data in here, L1, L2. It's my XY data. I'm going to go to my stat plot screen and turn on my stat plot. As you can see, I'm using the scatter plot L1, L2, and I'm ready to graph it. So I'm going to just press zoom 9, and there's my data. It's almost linear, so I'm going to use linear regression to make my equation in Y1. The button commands for that would be stat, then over to calc, and then number 4, lin reg. In order to put that equation into my Y1, I need to insert the variable Y1 right afterwards. And to do that, I'm going to press the vars button, then go over to yvars, choose function, and then choose Y1. Now when I press return, I'll see my equation, y equals 0.56-ish x plus negative 1.1-ish. And if I go to y equals, you can see that equation's been entered there for me. Look at all that accuracy. Great. So now when I hit graph, there's my model line, and as you can see, it models my data pretty well. I can see that based on the positioning of my line and my points, I'm going to have some positive and negative residuals. So let's find those residuals. To do that, we're going to use L3. I'm going to go to Stat, Edit, and I'm going to choose the title of L3 to calculate my residuals. To recall, residuals are found by choosing y data minus y model. And so to do that, I'm going to use a formula down in L3, which basically says that. The y data is found in L2, so I'm going to choose second 2 to call up L2. And now I'm going to subtract the y from my model, and I'm going to calculate that live by choosing y1 parenthesis L1. To choose that, I need to press vars, then yvars, then function, and then y1. So then y1 of L1, and inside of the parentheses, I need to insert L1, and that's second 1. So closing the parentheses, there's my command for finding the residuals. L2 minus y1 of L1, or y of the data minus y of the model. So when I press return here now, you'll see that's my residuals. Some are positive, some are negative, and they're all quite small, somewhat in the point something range, 0.1 perhaps. So those residuals, now we're going to do some statistics on those residuals. I'm going to quit out to the home screen now and press second quit. And let's do some 1 var stats on my residuals. And to do that, you press the stat button, then go over to calc, and then we choose 1 var stats. So 1 variable statistics. Now this is an important step to not forget. Before you press return, you need to tell the calculator to use the L3 list to perform the statistics. And so to get L3, which is where our residuals lie, you need to choose second 3 before you press return. So we're running the 1 var stats on L3. Why does this matter? Why do we care? What is the one statistic we care about here? Well, that's the third one down, the one that has the sigma x squared. This 0.11604 number, that represents the sum of the squares of the residuals. And that is an important part of the calculation of the root mean square error. While we're here, we can note that n, our number of values, is 6. And those two statistical variables have been stored in our calculator's memory. We're going to need them both to calculate the root mean square error. We're going to take this sum of the squares of the residuals. We're going to divide that by n minus 2. So in this case, we're going to divide by 6 minus 2. Then we'll square root that final answer, and that will be our root mean square error. So here we go. We're going to quit out to the home screen, and we're going to press vars and go down to number 5, statistics. That's where our statistical variables have been saved. I'll choose vars statistics, and then you'll see a variety of variables here. The first one I want is the sum of the squares of the residuals, so that's in the sum column, number 2. The sum of the squares of the residuals, I'll just press return now and choose that, and it calls it up on the home screen. I don't see what it is unless I press return, and there it is, that 0.116 value. I can calculate that with that now by dividing that by n minus 2. Now I know what n is 6, and I can subtract 2 from n in my head, and that's clearly 4. So I could just divide by 4 right now, but I'm going to take the long route there. I'm going to divide by the variable n minus 2. So I'm going to divide by parenthesis n. Now where does that? Well, that's under statistics again, isn't it? So vars statistics, and n is right there in front of us, number 1. So now n minus 2 can be calculated, close parentheses, and that's the next step in our calculation. We could have, again, just typed answer divided by 4, but I'm taking the long way there. So that is the sum of the squares of the residuals divided by n minus 2. All I have to do now is square root my final answer, and that will be my root mean square error. So I'm going to square root my answer and press return, and 0.170328-ish is my root mean square error. If you look at our list again of our residuals in L3, they should be all close to that value. So 0.17032, that's a great number. I don't want to have the calculator forget that. So I'm going to be a little bit clever here, and I'm going to store that value into another variable. I'm going to store that value into a variable r. So using the stow button it's above on, I'll press stow, and then using the r letter, which is above the multiplication symbol, I'm going to choose alpha r. That's going to store our value as soon as I press return into a variable called r. R in this case is just going to represent root mean square error. So great, so now we can use that more quickly. We can call up r whenever we need it. And I need it right now because I'm going to use it to modify my predictions. So I've got that model in Y1. I can use it to make a prediction based on the fact that my data goes from 1 to 6 in the X values. I'm going to use my model to predict 7, hypothetically. So I'm going to use my model to predict what would my line say at 7. Something bigger than you would see in our data values. If you looked at our data values, it's going to be bigger than 2.4 approximately. Okay, so here we go. Let's use our model to predict the y value at 7. So to do that quickly, I'm going to do vars, y vars, function y1, parentheses 7. So that is like saying plug 7 into my equation, and y1 of 7, according to my model line, is 2.82-ish. Great. So let's now use r, which is our root mean square error, to create a range of values. We're going to take 2.823-ish and subtract 0.1703-ish. To do that easily, I'm just going to press minus and then alpha r. That will give me my low end of my range. Then I'm going to use the up arrow and choose y1 of 7 again and add r. In this case, I have to press the right button here. Here we go. Adding r, and now we get 2.993-ish. I could have done that all in one step by choosing y1 of 7 plus r and y1 of 7 minus r all in one step. Let's see what that would look like. That would give me a little bit faster process. So again, vars, y vars, function y1 of 7. That would be my prediction. I won't see it because I'm not going to press return right away. I'm going to subtract r, my root mean square error, from that. That will be my low end, 2.653. That's exactly what we saw before when we did it the slightly longer way. And now again, y1 of 7 plus r, all in one line. To make life easy, I'm going to use the entry command to get the same command and just use the arrow to change the minus into a plus. Entry is above enter in blue. It's second enter. So second entry brings up my last command. I can then choose the left arrow and make that a plus. hit return, and boom, there's the high end of my range. So I've got my data, I've got my model line, I've got my root mean square error, I made my prediction with my model line, and using my root mean square error, my prediction is a range of values, in this case from 2.65-ish to 2.99-ish. I hope that video is helpful for you, and I hope you enjoyed it, and thanks for watching.